Hi. Centrifuge pile load test was conducted by Lopa, Juan, and Sergi under the instruction of Professor Milind Khire. As we know, piles are used to transfer load onto soil with deep bearing and side resistance. Pile screen friction may be highly dependable for foundation with low and bearing soils, and pile static load test is best method to determine pile bearing capacity and allowable settlement. The test was carried in centrifuge because centrifuge allows us to scale the sample. Overburden pressure can be multiplied with respect to the G's in the centrifuge, and also centrifuge is a faster way of testing. Now this is a typical example of pile foundation. The purpose of this experiment is to simulate a field pile load test on sand with axial load. Also, we want to investigate if the results from the centrifuge equation are comparable to the calculated results. Also, we would like to determine the friction resistance between wood pile and sand with respect to G level increase. The following data is used for the calculations. These are the scaling down parameters. A timber pile is simulated and subjected to axial load in sand. It is 24 inches long, which is buried halfway through. The diameter of the pile is 2 inches and it is circular with tapered end. The Q applicable is 181 kips at 50 G flight. Based on soil properties and pile dimensions, we calculated the settlement to be approximately 0.7 inches. We also assumed that the friction resistance will become constant at 15 G. That is basically due to the design rule of thumb that the settlement becomes constant at the depth of 15 times the diameter. This slide shows the settlement versus G data from our experiment. The general trend of the curve obtained from our experiment conforms to what we expected it to look like. Once the peak G of 50 was reached, the centrifuge was decelerated as shown in the video. As you can see, the pile did not rebound fully due to the elastic settlement of sand during flight in centrifuge. The obtained results show a close correlation between measured and calculated allowable side resistance. The values match with the values obtained from the flight. From 0 to 30 G, the friction resistance has direct correlation with the G's. At about 30 G, the measured friction resistance increased dramatically, probably due to the increase in the density of sand. An overview of our results as well as possible errors in the experiment are presented in this section. Special thanks to all those who were involved in this project. Thanks for watching.